This time I'm going to put the heart up a little bit higher. We're going to look at blood vessels that are found in the upper extremity. Bless you. A little bit lower.
You know I think you messing up and you're tripping.
I didn't touch anything.
Drawing it over and over.
See, now we're gonna draw on you
I know, no, no.
instead of you. We're gonna draw on you.
I didn't even touch it
We're gonna do
yesterday.
that today.
So the first vessels to come off of the aorta are the right and left coronary arteries. And then we have the ascending aorta. And the next portion of the aorta, arch of the aorta. And the first branch off of the arch of the aorta is brachiocephalic trunk. Okay? And that forms right common carotid and the subclavian. And then the next branch is the left common carotid and subclavian. Okay, hopefully you can follow along with that. We did the carotid branches, internal carotid and external carotid. And we had vertebral, which was also supplying blood to the brain. Thyrocervical trunk, which sent branches to the shoulders and over to the neck. And then we finished off, before we went to circulatory system of the brain itself, we had the internal thoracic. Okay? So now we're going to follow the subclavian vessel artery down into the arm and upper extremities. So it passes along the upper chest, and just as it passes deep to the clavicle, when it emerges from the inferior border of the clavicle, it is identified as the axillary artery. Okay, so that's the decision point. That's when we change from subclavian to axillary.
That's when it goes under the clavicle?
So when it emerges.
When it emerges, okay.
So when it reaches this edge, so it's subclavian until it exits from the clavicle. All right, I don't have my lecture notes with me. I pulled them up on the screen, but they're too far away, so you guys are going to have to tell me the numbers. So subclavian was what letter? I mean, what number?
19.
19.
Oh, subclavian, sorry, is 14.
14. And then I'll identify the clavicle here. And once we emerge from that, we have the axillary. And what number is that?
19?
Now the axillary artery is passing through the axilla, which is the armpit. It actually has 6 branches, 3 sections. It's kind of neat. The first section has 1 branch, the second section has 2 branches, and the third section has 3. But the axillary artery, we're not going to name all of those. Those branches go to the muscles of the scapula. So remember infraspinatus and teres minor and teres major. So those branches are going to go to scapular muscles. And to chest muscles. So pectoralis major and minor. Then it passes another border. This is a muscular border. So when it passes when it reemerges under the inferior border of the teres major, it's now the subclavian artery. Now the brachial artery, meaning arm. Remember biceps brachii and coracobrachialis. So now it becomes the brachial artery. Is that 20?
Yep.
So brachial artery is going to supply both anterior and posterior compartments of the arm. And just above the elbow, it divides into two vessels that supply down the lateral and medial aspects of the forearm. So lateral bone of the forearm is the radial bone, so that's the radial artery. And on the medial aspect, we have the ulnar artery. Well, what are my numbers?
Radial is 21, ulnar is 23.
And these are found in the anterior compartment of the forearm. But they have branches that pass between the radius and ulna to supply both anterior and posterior. So our radial nerve did posterior forearm muscles, but both the radial and the ulnar artery are going to be found in the anterior forearm. So if you're drawing them on yourself, you want to draw them on the anterior aspect. When we get to the palm, or to the wrist, and then to the palm of the hand, these vessels join together to form two arches. One lies superficial to the muscles of the palm of the hand, all right, and the other one lies deep. So remember we talked about adductor palmaris and lumbricals and all of that. So the superficial one is formed, it gets its blood primarily from the ulnar artery. And then it's going to rejoin, because this is a loop, it's going to rejoin with the radial. So a smaller vessel from the radial helps to form that loop. And then the reverse is true for the deep palmar. The deep palmar is a little bit shorter. And so a small vessel from the ulnar is going to join a large vessel from the radial. So superficial is what number?
23.
Okay. So superficial palmar artery. It's most of its supply via the ulnar artery. And deep palmar artery gets most of its blood supply from the radial. Actually, the radial artery comes around and passes in that web space between your thumb and forefinger to form that deep palmar arch. And then there are vessels that extend out to the fingers. Do you remember where the nerves were found, the digital nerves that carry sensory information from the fingers are found? Are they found on this surface, or this surface, or this surface primarily? The major ones.
On this side.
They're actually lateral. So if you slam your finger in the door, you're less likely to pinch and kill that nerve if you do it this way than if you do it that way. I mean, it'll still hurt both ways, all right? But if you slam your finger in the door this way, the tip of your finger is going to be numb for a few weeks until that nerve grows back. Personal experience. All right, so the left subclavian vessel is going to do the same thing. All right, it's going to look exactly the same. It comes directly off of the arch of the aorta, but as far as what happens in the top of the thorax or in the arm or in the forearm, it's going to look exactly the same as we see with the right side. Now, if we were tracing a drop of blood, and I said trace a drop of blood to the left little finger, you would have a difference because you would be missing the brachiocephalic trunk. Okay? So if we were tracing a drop of blood from the heart to the left little finger, it would go ascending aorta to the arch of the aorta, instead of going through the brachiocephalic trunk, you'd go directly into the left subclavian artery, then axillary, brachial, and left ulnar artery. Okay? So you would have one less step because you would be missing the brachiocephalic trunk. Before we come back and look at the chest, the blood supply to the chest, blood pressure determinations, if you've ever had your blood pressure taken, you use the stethoscope and the little valve is called the sphygmomanometer. You compress the brachial artery and you place the stethoscope right at this point here. What happens when you listen to blood pressure is here's the brachial artery, and as you inflate the blood pressure cuff, you collapse that brachial artery. And so no blood is flowing through it. And when you listen with the stethoscope over the brachial artery, you don't hear any sounds. As you turn the valve back and open up the escape valve so that air can move out of the cuff and less pressure is placed, then as the heart is pumping, it's pushing against the vessel wall, and eventually as air moves out of the blood pressure cuff, the heart's force of contraction during systole is able to push some blood through the brachial artery. And the theory is that that creates a turbulence as each time that the blood flows through. When the heart is at rest, there's not enough pressure to push blood through. And when the heart contracts and that volume of blood comes down the arteries and it pushes through that narrow portion, you hear a disturbance, which is known as the sounds of cortical. So every time you hear a beat, in fact, you can almost feel it sometimes in the blood pressure cuff, all right? When you're listening with the stethoscope, you're not hearing valve sounds. You're not hearing the AV valves and the semilunar valves closing. You're hearing a thump, thump, which is the blood apparently hitting the vessel wall. So that air keeps escaping, and as that air keeps escaping and pressure is decreasing in the blood pressure cuff, the blood vessel is dilating until eventually the pressure in the cuff becomes slightly less than the pressure in the blood vessel when the heart is in diastole. And the blood vessel now no longer shows a disturbance as the blood flows through it. And you stop hearing the sound. So if you're manually taking someone's blood pressure, you put the blood pressure cuff on, pump it up to about 150, unless you know their blood pressure is really high. But you pump it up to about 150, meaning 150 millimeters of pressure collapsing that blood vessel. And most people's blood pressure is between 110 to 130 something. So that's going to collapse that blood vessel, and as you decrease the pressure, the heart's systolic pressure will eventually be greater than the blood pressure cuff, and blood will move through. You'll start to hear thump, thump, thump. As you're actually watching the needle of the valve, known as a sphygmomanometer, that's the valve with the needle, and it starts to move down with pressure. You can actually see that needle start to blip. Even if you're not listening with the stethoscope and they're doing it on you, you can see, okay, that's about when my heart pressure is great enough to overcome the blood pressure cuff. So that first number that you hear is going to be the value of the systolic pressure. The pressure when the heart is contracting great enough to push blood through the collapsed vessel. Then as the pressure in the blood pressure cuff drops, finally the heart's pressure at rest is greater than the blood pressure cuff, and you no longer hear any sound. So the last sound that you heard, the number that the needle is pointing at, would be the diastolic pressure of the blood vessel. Okay. But typically taken at the brachial artery. All right, now let's look at blood supply to the chest wall. And we've looked at the internal thoracic artery. So don't have these vessels on there that I'm gonna draw in. I will write them in. But I want you to know this. So coming off of each subclavian, we have the internal thoracic artery. And I showed it to you on that breastplate from the model. So it's running down just lateral. I have a little wide here because my heart's in the way. But it's running down just an inch or so away, just lateral to the sternum, on the deep surface of the chest. And branches come off lateral. So this would be the internal thoracic artery. And branches come off in this direction. I mean, there may be some small ones that fly to the sternum, but the major vessels are passing laterally across the chest and around the side of the chest. So these are all anterior intercostals. So write that in because I don't have that on the list, surprisingly. And they're going to meet branches coming off the back of the aorta. And this is the thoracic aorta. What number do I have for thoracic aorta?
27.
27. So this is thoracic aorta. It's going to come down slightly to the left and behind the heart. And then it will pass through the diaphragm and become the abdominal aorta. I'll draw a different, I'll leave that up and draw a different picture. Coming from the back of the heart, and passing to the side and around and joining with the anterior intercostals in this fashion. All right, so these would be the anterior intercostals. These would be the posterior intercostals. And they actually join, physically join together. So the posterior intercostals join with the anterior intercostals and run in between each of the ribs. Supplies blood to the ribs and the intercostal muscle. Now, you won't see this on any model, the next vessel that I'm going to talk about, the bronchial arteries. None of our models show that because it's between the heart and the thoracic aorta, but you will see it on diagrams. I'll make sure of that. Where do you think the bronchial arteries go?
Heart? Or to the lungs?
To the lungs. So, are they carrying oxygenated or deoxygenated blood?
They're going to carry deoxygenated.
Coming off the aorta. I know. You haven't had your coffee or your sugar boost or whatever yet. There's actually more than one. But these are the bronchial arteries. Why do we need to carry oxygenated blood to the lungs? Okay, so what kind of blood is in the pulmonary arteries? That's deoxygenated, because remember it's coming out the pulmonary trunk and carrying deoxygenated blood to the lungs. And then the pulmonary veins, which are carrying oxygenated blood, are leaving the lungs to go to the rest of the body. The lung tissue, obviously, is doing work. It has muscles and connective tissue and collagen fibers. So yeah, the simple squamous epithelium of the alveoli are in direct contact with the oxygen. They can get their oxygen from the air, but we've got bronchioles that have cartilage and smooth muscle. And we have simple cuboidal cells in the bronchioles, and they have a thick mucus over their surface. Oxygen's not going to diffuse through that very easily. So the lungs need their own source of oxygen to do work, and that's what the bronchial arteries are for. Okay? Yes?
Sorry to go back just a tiny bit,
Uh-huh.
but the anterior and the posterior intercostals, do they both branch off the aorta and then meet back up?
No, the anterior intercostals are coming off the internal thoracic chest. So I did put a picture up here this morning when I was in the office, so let me switch over.
So where are the posteriors coming off of?
Yeah, posterior coming off the thoracic.
Posteriors are coming off the posterior surface of the aorta.
Well, you said they meet, I just,
They join, so they become the same vessel in the lateral aspect. Well, good thing I didn't want to use the PowerPoint today. Well, I'm not wanting to switch to the computer, so. It is. It's not saying it, it's all right, we'll see what happens. On my controls up here, it's not going to the computer. so. Okay, but anyway, there is so it's like you had a wire here and then a wire going around and attached to the aorta in the back. So on the models, you'll be able to visualize that. And I have a picture after class if you want, but I can't do it on the screen. Okay? So that's getting blood then to the chest wall, and that's getting blood to the lungs. That's oxygenated for the lungs to use. So that's the role primarily of the thoracic aorta, is to provide blood via the posterior intercostals to the chest wall. So I'm going to leave this up here, and now I'm going to redraw it from the diaphragm down over on this side. So we'll move, you guys see over here? Or is it better if I draw on this board? It's easier for you to see. This one? Except for the people that are already over here. This one, how about here? What at this end? So this is the diaphragm. I could do both. I'm very talented. And so the aorta comes down just slightly off center. And once it passes through the diaphragm, it is considered to be the abdominal aorta. Now, when you read in your textbook or other places, it will talk about the descending aorta. I prefer to separate these as two separate components. So, abdominal aorta and thoracic aorta. Abdominal aorta is 46 on your number. We're going to do a whole bunch of things above that. So I'm going to draw the entire aorta down to its split, but then with my finger I'm going to erase where the vessels are coming out. So give me before you draw what I'm drawing, just hold on a moment. The aorta ends at the top of the pelvis by forming two branches. So this is the abdominal aorta. A pair of vessels comes off the top that supply the diaphragm. Anybody remember what nerve supplies the diaphragm?
The
Phrenic nerve, all right, that's our word for diaphragm. So these blood vessels that supply the diaphragm, and it's the inferior surface of the diaphragm that's being supplied, are identified as the inferior phrenic arteries. There are superior phrenic arteries, but they are going to be the terminal branches of our internal thoracic, and I don't require you to know those. So these are the inferior phrenic arteries. I looked over there at the board, but I didn't see the number. What's our number?
31.
So in this case, the name of the blood vessel tells you what structure is being supplied by blood, the diaphragm. The next vessel to branch off of the abdominal aorta has three branches. So remember what we call a vessel that branches very early and the vessel itself doesn't really go anywhere? Like the pulmonary trunk supplying the right and left pulmonary arteries, and the brachiocephalic trunk supplying the right common carotid and the right subclavian. So this next vessel is identified as a trunk because it itself doesn't provide any organ or tissue with blood, it's supplying branches. So this is about an inch to an inch and a half long vessel. And those of you that had me for Bio 430, we actually looked at this vessel because it was the site of the ganglia formed by the greater splenic nerve, where the postganglionic neurons coming, the preganglionic neurons coming off of the thoracic 5, 6, 7, 8, and 9 form the greater splenic nerve that passed through the diaphragm and ended with postganglionic neurons on either side, whether they were right or left, of this vessel. Anybody remember the name of that ganglion? Start with a C?
The ciliary.
Celiac. Celiac ganglion. And this is the celiac trunk, so that's why it's called the celiac ganglion, those postganglionic neurons. So this should be 32, I'm assuming?
Yep.
Mhm.
The celiac trunk has three vessels branching from it that supply three different organs. One is the spleen, one is the stomach, and the other one is the liver. And those are the names of its branches. So 33 should be left gastric, am I right? That's the first branch to come off. What organ are we referring to with gastric?
The
Stomach. And the stomach has a J-shape form. And so this first vessel comes around and starts to line the inside of that curvature of the stomach. And it's known as the left gastric, because it comes down the left side of that curvature of the stomach. The next vessel is supplying the spleen. The spleen is an organ we'll look at with the immune system. It's tucked up way up high under the diaphragm over on the left side of the body. And so the next vessel actually passes behind the stomach. All the way over to the spleen. So it's called the splenic artery. So the left gastric is kind of small. Splenic is much larger.